Hello, my name is Zishan. Welcome to Easy Math. Today we're gonna look into distance time graphs from the topic 1.2 motion, igcse physics 0625. I have created one video based on distance time graphs, but there are a few things remaining from distance time graphs that we should discuss, and we are also going to solve a few questions based on those graphs. So let's see with the topic, which is finding maximum speed from a distance time graph. Now, finding speed at one particular value of time is something we have seen in the previous video. Today, we're going to see how we can find out the maximum speed from a distance time graph. Okay, so let's see. Well, let's say there is a distance time curve given to you. Let's get rid of this on the right. And the distance time curve on this graph goes like that. Or maybe let's draw something like that. Okay. Now, if they want you to find out the maximum speed from this distance time curve, you need to locate the point where you think the gradient of this distance time curve is the maximum. So what I do is I'm going to do it mentally, but for you to understand, I'm going to draw tangents at this curve. And I see somewhere around here is where the tangent is the most inclined to the x-axis. See, look at the angle it makes with the horizontal, the tangents. Look at that, this angle. Well, the most inclined tangent is somewhere around this region. So what I do now is I actually draw a tangent at that point. So somewhere there, that's our tangent. And what I do now, I'm going to find out the gradient of this tangent. And the gradient of a tangent, I simply have to read out the x and y coordinates of this point and x and y coordinates of this point. The gradient would be y2 minus y1 divided by x2 minus x1. Now, well, that's about it. So this gradient, well, one thing I've been repeating from the previous video, gradient of a curve on a distance time graph is the speed that the object is moving with. And that is why the speed here is going to be the gradient at that particular point. And that is actually the maximum speed. Speed that you calculate on any point on the curve would be smaller than the value that you have here. And that is why this is the maximum speed, only because the tangent is the most inclined at that point. Okay, so that was the first concept. There were we could have taken some numerical values to this, but it's actually the same y2 minus y1 and x2 minus x1, the same formula for gradient. It may have been a 10 and a 70, and this may have been a 5 and a 35. So the speed would have come out to be 70 minus 35 divided by 10 minus 5. That would have been 7 meters per second. That's it. Okay. So that was one thing that I wanted to discuss. We're going to do questions based on it later on. And the other thing is calculating average speed from a distance time curve. Okay, so average speed from a distance time curve, how are we going to find that? So here we go. Let's say there is a distance time curve and there are different distance values. So let's say it ends up at 70, there's a 60, there's a 50, there's a 40, 30, 20, and 10, and then there are time values. let's say 10, 20, 30, 40, 50, 60. And then you have the curve, which maybe goes um, like that and this way and like that. Well, looking at how the curve changes, it's hard to uh, uh, find out the speed. But if they have asked you for the average speed, you should know the formula for average speed is the total distance the object has moved divided by the total time taken by the object to move that distance. Well, I see that the object has moved a total of 70 meters in a time of about 60 seconds. Well, average speed in this case would simply be a 70 over 60 or a 7 by 6 meter per second. No need to analyze what is going on in between the 0, 0 point on the curve and the 70, 60 or a 60, 70 point on the curve. The average speed is going to be the distance that you see at the end of the curve, distance that is at the end of the curve, and the time that is at the end point of the curve. You simply read that. And remember, the formula is supposed to be total distance by total time taken. And that's about average speed and how you find it from the distance time curve. Okay. Now, and of course, the formula I want you to remember, distance is equal to speed into time. We can iterate this to give you speed also, distance divided by time, or time is gonna be distance divided by speed. That's also a way you can use this formula. Average speed, like I told you, is gonna be the total distance that you see the object has moved divided by the total time it has taken for the object to cover that distance. Okay, so we don't need to look at the intermediate state of the object. It needs to be the final distance, the total distance the object has moved and the total time it took. Now we're going to go and solve some questions. Well, I usually use the Kindle book, Kindle P4 book. You'd see uh, there are previous year topical papers collected by different um, uh, brands which have published their collections on Kindle and Amazon. So you can go and buy Kindle P4 book. It's a collection of topical past papers. Topic wise, they have divided the questions from the previous years. We're going to do this. Let's see. Well, okay, we can discuss this also. See, here you have uh, two distance time graphs given, and they want you to describe the motion shown by the graph C and the graph D. Well, I see as the object moves ahead, and we should reduce the size of the ink, and I see if I draw tangents to this distance time curve, I see that the tangent reduces in slope. It falls down. It flattens out. Well, tangent of a distance time curve is supposed to be speed. If the slope of the tangent reduces, it means that the speed has been reducing. So what you're looking at is a decelerated motion. You can deceleration or reducing speed. That's the kind of motion you're seeing. Here, I see that it's a straight line between distance and time that represents the relationship. While the tangent, if I draw it, the slope of it is not changing, meaning the speed is constant. So I can actually list here for the graph D, constant speed. And that should be the answer for this question. Let's look at another question. Okay. Define acceleration. Well, we'll talk about it later on. Here, we're going to only talk about distance time graphs. Describe the motion of the cyclist in time between 0 and 15 seconds. Okay, so let's see. So 15 seconds is somewhere here. Okay, so I see that the tangent of this curve is sloping upwards as we go in time. It means that the speed is increasing. And initially, the tangent on the curve was a horizontal line. Okay. If the tangent slopes upwards, this is a accelerated motion because the velocity is increasing. Accelerated motion, increasing speed. That's what it literally means. Okay, between 15 and 30 seconds. So let's see, 15 and 13. So I see it's mostly a straight line between 15 and 30. If the line representing distance time relationship is a straight line, it means that the speed is not changing and it is a constant speed. And between 30 and 40 seconds, let's see. If I draw tangents again to that curve, I see that the tangents are flattening out. The slope of the tangent is reducing. And as it reduces, I'll very nicely write up here that the uh, velocity or the speed is reducing. And this is decelerated motion. There. Done. Okay. Now they can actually ask you about the average speed from this distance time curve. Okay. We can find out the average speed, which is the next part of this question. What I do is I draw a straight line just to see the distance it has reached at the end of the journey. And when the time was 40 seconds, I see it's a 300 meters in 40 seconds. So I go average speed is going to be for 2 marks. So I will actually include average speed. Average speed is going to be total distance divided by total time. So we go 300 divided by 40. I think it should be a 7.5 meter per second. That's your answer. Maximum speed. Okay, that we're gonna have to see. Well, like I told you, the speed is increasing between 0 and 15 seconds. Then it is constant and then it reduces. Don't you think that the speed is the maximum in this region? That's where it has the maximum inclination to the x-axis. That's where it is the most inclined. If I draw the tangents, you'd see that this particular line has the greatest inclination or the greatest angle of inclination with respect to the x-axis. Well, I'm going to find out the gradient of this line. Well, how? Well, I go drop maybe 2 horizontal and vertical lines just to find out the coordinates of these 2 points. So here we go. There. Well, I'm only going to find out the gradient of this line. The coordinates are going to be 30 and a 250. And for this one, it's supposed to be 20 and a 110, 120, 130, somewhere around 110, 120, and 130, 127.5. Let's take a 127.5. Again, if I had a printout of this paper and a ruler and a pencil, I would have been better with my coordinates. But for me, this is what it looks like. So I go find out the speed, which is the gradient of this line. It's going to be y2 minus y1. So you go 250 minus 127.5 divided by 30 minus 20. comes out to be, let's calculate this, must be about 122.5, I think. 250 minus 127.5 divided by 10 comes out to be a 12.25 meter per second. Well, that's your answer. We go and write this up. Maximum speed is going to be the calculation that we did there comes out to be 12.25, 12 point, maybe 3 meter per second. That's where we'll end it up. 12.3 meter per second. And that's all. Okay. So that was another question that we could have solved with the knowledge of distance time graph. Here, again, we have a distance time graph. Let's see. Describe the motion between Q and R. Well, again, it looks like a straight line between Q and R. So we have constant speed. R and S. Well, I see that the slope of the curve is reducing, meaning the speed is reducing. And then S and T, I see that the distance between S and T has not changed at all. So the object is stationary. So object is not moving. That's all. That's all we tell them about. Calculate the speed between U and V. Okay, speed between U and V. Again, it's a straight line. What we do is we find out the gradient of this line, and that's about it. For the gradients, we're going to need the x coordinate and the y. For this one, it's going to be 300, and I think it's going to be 410, 420, 30, 40, 50. Yeah. No. It's going to be 420, 440, 460, 480, 500. So 20 for each block. So this one's going to be 440. So there, and the speed is going to be 600 minus 440 divided by 400 minus 300 comes out to be 140 divided by 100, 1.4 meter per second. That's your answer. Oh no, 600 minus 440 is a 160. So you reduce them and it comes out to be a 160. So you go, it's supposed to be a 1.6 meter per second. That's it. 1.6 meter per second is the speed of the object between U and V. That's your answer. I could have written it there. Okay. Well, there were a few questions and we should, I think there are a lot more of these ahead. And in case you find these kind of questions difficult, you can post up I'm also going to upload the PDF of the book that I'm referring to. You can do a lot more questions from that PDF. For now, I'm going to end it here. You have a good day. Bye. That ends distance time graphs though. Bye-bye.